In this video, I'll be discussing about abstract data type, that is ADT. We'll learn what is ADT, and that I will explain it through an example, that is list example. So we will learn about list ADT. So first, let us learn the term ADT. ADT means abstract data type. So in this, you leave the term abstract. First, we will learn about data type. What does it mean by data type? So a data type is defined as representation of data, and second thing is operations on data. So a data type is defined in two terms. First is how the data is represented, means how you are storing the data. And second thing is what are the operations that you allow on the data. So if I take an example of a integer data type in C, C++ languages, then if we assume that integer data type takes 2 bytes in C, C++, if I assume that, then once I declare any variable of type integer in C, C++, we get memory of 2 bytes. That is 16 bits. So these are 16 bits. So integer type data is stored in 2 bytes together as a single value, as a single data. Now in this, 1 bit is reserved as sign bit to allow both positive as well as negative numbers, and rest of the 15 bits are allowed for storing data, that is any number. This is 1 bit. 1 bit for sign bit, and remaining bits are meant for storing a number. This is how an integer is represented inside the memory in 2 bytes. So this is the representation of integer data type. So as I said, that representation of data and the operations of data. Example of an integer I have taken. So integer, this is how it is represented. So this is the first thing we have covered. Then what are the operations allowed on integer type data in C, C++ languages? That is, arithmetic operations are allowed on them. That is addition, subtraction, multiplication, division, and modulus. Apart from this, relational operations, that is less than, greater than, and increment decrement operators are allowed, that is plus plus or minus minus, both pre-increment and post-increment. So these are some of the set of operations that are allowed on integer data. So that's all. This is a data type. So if you talk about a data type, any data type in a language, then that data type will have its representations and the set of operations on the data. So when we are learning any programming language, when we learn any data type, we learn mostly about its operation, and sometimes we go into detail and also understand its representation. Now let us see what is abstract. Abstract means hiding internal details. Now if I take this example, integer data type and these operations. For performing these operations, do we really need to know how they are performed in the binary form inside the main memory? No. We are concerned about declaring a variable and using it by performing these operations. So we need not know internal details how these operations are performed. Right? Without knowing them, we can use them. So these things are hidden from us, so we can call them as abstract. Without knowing internal details, we can use it. So internal details are abstract for us. So this is the example of a primitive data type I have taken and explain you meaning of data type and meaning of abstract data type. This is not abstract data type, this is primitive data type. Now the term abstract data type, why it is introduced, what is the meaning of this one? See, this is related to object-oriented programming languages. When the object-oriented programming languages being started used in software development, then using the classes, we can define our own data types that are abstract. That is, without knowing internal details, we can use them. So this term is related to object-oriented programming. So let us take an example of a list and define it as abstract data type. Let us take the example of a list. That is list of elements or collection of elements. So if I say list of elements, I'll take few numbers randomly So here I have taken the list of elements. Now I can give the indices either starting from 0 or 1. That depends on my requirement. That depends on my definition. So I'll start indices from 0 onwards. So this is 0, 1, 2 and so on. This is a list that is collection of elements. Now this is a list, this is on paper. Now I want this list to be used in my program. Then how I can represent a list? So what are the things that I have to store for representing the list? So the data that is required for storing this list is, first I need space for storing elements. Then the second thing is I need to have some capacity of a list. Then the third thing is inside that capacity, how many elements already I have in a list, that is length of a list or size of a list. So the third thing is size of a list. So for representing this list, I need three things: space for storing the elements, and its capacity, that is maximum capacity, and its size, that is number of elements it is having. So for representation of this one, I have two options. One is I can use array in a program, or I can use linked list. So representation of a list can be done using any of these representation, any of these methods. Then let us look at operations on a list. What are the operations that we perform on a list? Now for the operations, I will write few operations here. Then again, I will explain all of them. So the operations that I may be performing on the list is, in this set of elements or the list of elements, I can add more elements. So the operations that I can perform is add an element, that is X, or I may want to remove some element from this one. So remove an element, or I want to search for any particular element. So let us say it is search. I want to search for any element, key element, like this, so on, so on. I'll be discussing all the operations afterwards. Now let me finish abstract data type here. See, this list is an abstract data type. It is having the representation of data and the operations on the data. So when you have two things, data representations and operations on the data together, it becomes a data type. It becomes a data type. Now this I can put together